So, hello to everyone. I am Kirill Vasin, a PhD student from Augsburg University, and Kirill Belov is a C# developer working in Engels, Russia. Today, I will make a brief overview with a guiding presentation on our applications that we developed together. Firstly, let's just clarify from the very beginning what it is. Firstly, it's an open source notebook interface for Wolfram language, or more specifically for Wolfram engine. It's a desktop application in general. And also it's a set of JavaScript modules and Wolfram libraries implementing various front-end functions like standing for graphics, sound, syntax sugar, and even dynamics. And what is not, it's very important that it's not Mathematica killer or replacement, because we are targeting it as a competitor to Jupyter kernel, which was already available online since 2019. And we have some specific things which won't work in Mathematica and vice versa, but in principle, kind of compatible. And it's not a web application in a common way. It's similar to Visual Studio Code. So we use web technologies, but for rendering interface in desktop application. But of course, using web interfaces allows us to easily export notebooks to the web, even keeping some dynamic elements working. Let's just overview. So now what's opened, it's an empty notebook where you have cells, and the cell type is determined by the first line where you type extension. And there are many cells available by the default. So first one is Markdown. Markdown, more traditional way. So we also have JavaScript cells. And we can also write HTML code. You got the idea. So the first line just tells what's an expression, what type of a cell is. And if nothing is specified, it's just a regular Wolfram language. So let's start from a classical example showing off the symbolic nature of Wolfram language, where all Jupyter users just freaks out. So for example, we have a sphere. We make graphics 3D. Okay. This even Jupyter can do, Jupyter kernel. But in our case, we really just implement it in a way how it's done in Mathematica. So we can edit the output cell and replace sphere with cuboid. Okay, now we have a cuboid. So there's still expression. We can, for example, copy and paste it multiple times, and then we get the cuboid in the power of 3. Let's talk about the dynamics, because I think it's also interesting for you guys how we implemented that. We use a little bit different approach. Okay, actually not a little, but completely different, which is actually quite low level. So what you can see here is a fluid simulation working in real time at the edge of capabilities of Wolfram engine. And this function, it's not some single function which is designed specifically to draw and update all of this that we see here. Basically, it's a graphics primitives with arrow primitive, Q, which are coupled to some dynamic symbols that we have there. The drastic difference with Mathematica is that we couple this symbol only to hue or only to arrow. If in Mathematica all boxes and expressions are immutable, here we are working like in JavaScript world, and it's more like object-oriented approach. Therefore, arrow is an object which is presented in DOM, and we can selectively update only the arrow without reevaluating the whole thing, which allows us to do some stuff like this. So, for example, like can append objects and using the same additional primitives, change their size, position, and radius, and it works quite fast just because we only update the specific property, the specific attribute, not reevaluating the whole thing. Basically, here it's the creation of graphics polygon in WebGL and 3JS libraries. It has some gizmos, and it's again just Wolfram language primitives that we use to do that. And maybe we can also just quickly show how manipulate works. Despite the fact that our architecture differs quite seriously from Mathematica, we still can provide to a user simple tools for making such things like manipulate. Okay, X from okay, how it works. But for some more complicated things, we also prepared more specific functions like manipulate plot, which treats more efficiently quick updates of any variable. Yeah. And under the hood, the whole dynamics of manipulate plot and all examples that I did show to you is made using the event-based approach, basically. So let me give you an example. For example, I would like to make a slider which controls the radius of a disk. So let it be radius 1. And then we use event handler and input range primitive. We specifically didn't call it slider because otherwise it will confuse people. And then the second argument is a handler. Okay. See if it works. Okay. Now is 0, 0. And here we use a keyword path load, which acts similar to basically dynamic. Got graph. And again, it does not reevaluate graphics box or primitive. It only acts on disk and changes only a single attribute. So the dynamic symbol is always coupled to its parent. So what we have in the backend is just a Wolfram engine or Wolfram kernel, which runs a web server. And we recreated the whole stack of like TCP, HTTP, WebSockets, and even the sockets interface for Unix, POSIX, and Windows systems. Because native sockets is based on 0MQ library, which has like the speed of like 3 megabytes per second or something very slow and buggy. So we re-implemented in C from scratch, which now gives us, I don't know, 500 megabytes per second, or maybe. So it's already enough. Then it provides basically a rendered windows to the front end. So, so the structure, the template UI, everything is pre-rendered. And then the JavaScript kicks in. It communicates with the kernel using VXF and via WebSocket protocol route, so it's bidirectional. And what we do, we basically supply from a backend the commands in the form of Wolfram expressions. So on the front end, we have a sort of a tiny Wolfram language interpreter. So it's capable of doing some simple mathematics, sine, cosine. In a case if, for example, you make a plot where you don't have pure numerical values, but you have something like polygon of sine, cosine, whatever. So it's capable of like interpreting them and converting them to JavaScript objects. And in the same manner, we also handle all UI, basically all your actions. So when you click on a button or do something, it sends an event to a kernel, and then kernel decides what to do with that and sends back to the front end, basically like Wolfram expression, which then execute and change something in DOM struct. What differs from Mathematica? From then that we have the flat notebook structure, and it's not directly compatible with NB format. And the standard output form is a sort of decorated input form. So basically they're compatible. All standard form outputs that you have from VLJS, you can substitute back and it's gonna work. We did not cover all the boxes of Mathematica and graphics primitives. It's still like a huge, like large work to do. But yeah, like for most functions, it's already like in a decent state. As I said, no dynamic expression. I mean the keyword, so we use a bit different architecture. Button sliders we replaced with our own stuff. As I also demonstrated, it's event-based approach in dynamics. So we assign a handler for a slider or for a button, and then does something. Granular dynamics, as I already said. And the cool thing about working in web is that, yeah, you can, in principle, convert everything to just pure JavaScript and HTML. So what I can show it to you, that we have like sort of demonstration project. And if you go, for example, into manipulation, you can see that all expressions are working, even though it does not communicate with Wolfram kernel at all. So it's just purely within this page. But it doesn't mean that we compiled Wolfram functions into JavaScript. It would be really cool, but almost impossible to do. So it just uses pre-calculated values for all dynamic symbols used in a notebook. So it's kind of automatically samples it and converts it into a giant hash map, then compresses it usually using gzip and ships it to a page, which is absolutely static. I will firstly show that all this presentation was created in Wolfram. As you can see, it's just again a notebook with a specific cell called slide, which uses Markdown and Wolfram language together. Even the last picture that you looked at, it was just this famous Escali draw plugin, which is also working here. For example, you want to create a slide, just type .slide. It's based on Reveal.js library. It's very nice. So then you evaluate, you have your slide. Okay. So I can also make a picture. Just drop here. And it uploads it. So now I have it here. Another freedom that we have here is that we can make some figure. And we embed it like this. As I said, it's similar to JSX. Maybe you have heard about that. So like if it starts from a capital letter, it's treated as Wolfram expression. And you can also supply some options there, but it's a different story. And you can also go full screen and so on. The cool thing about that basically what it allows you to do, this combination of Markdown, HTML, and Wolfram language. For example, you generated something on Wolfram, you want to stylize it in a very specific way. So instead of coming up with some specific way of decorating it using Wolfram language functions, you can use just pure HTML. I have a good example here, for example, Helix tables. So what we have here, we generate data firstly in Wolfram language, and then we supply it to some function. As you can see, it's just a combination of tables and with, and we immediately here have here HTML, and it's just, In this regard, like using CSS and HTML, you have a bit more freedom than like in regular notebook, using just Wolfram language functions. You can, let's go further. You can use JS. So, for example, I define some function in the context of core. It's similar aka global. And here I define some function in JavaScript world called my function. It takes argument, the first argument, data, and then returns it as an array and substitutes it to the last position. So if I call it right now, using front fed, I got, so we have a one-to-one correspondence between JavaScript functions and Wolfram language. And we use VXF like to optimize the data transfer. So in the way that if you like streaming video, it won't be multiple times parsed serialized. It's just raw bytes which are transferred and then chopped into pieces and sent to GPU. Another example maybe, yeah, basically what you see here, like that's how all boxes are made, like most of the boxes, and all graphics and graphics 3D is just some function which is defined in or other context, which does something with data and returns either value or a DOM object or whatever needs principle. We can also can create some object using JavaScript. Actually, yeah, can create and substitute it to the notebook structure, for example, but I will do it a bit differently. Just it's just some directive which creates a DOM element automatically and executes within its context this JavaScript function, which then gives me, so now it's a DOM element, and here we just set its inner text to the data that we get as an argument. That's again how here the JavaScript integration within cells work. Yeah, another thing maybe, as I said, in Markdown mode, you can also draw. We just integrated this Excalibur format. In principle, we have a plugin system for our system, and anyone can write their own extensions and integrate some other things. Okay, now maybe the time for AI assistant. So, for example, I open the command palette and say like, show me some example in Wolfram language. It spawns a chatbot which has a full access to the notebook. So it can read the right cells, but sometimes it's a bit stupid and it does not realize that it has to print cells actually, but not write to a chat. Print, please. Wow. And it also has a library which has an access to our documentation, to our specific functions, so we can actually ask it to show me dynamic example in VL. Please read library that, to make sure that it will actually read. Because we have quite big documentation on our specific functions, and we don't want to spend all tokens on just that. Oh, thanks, but so many. We just ask for one. Anyway, it also has an access to Wolfram Alpha, and yeah, can evaluate cells, read them. Oh, okay, give it to me. It's just I will ask it to evaluate it. Evaluate all JS cells you create. Might be dangerous. Okay. This is actually quite interesting because it's creates animation cycle and even assign a handler. So in this context, when you remove the cell, it cancels the animation frame. It was very hard to teach it because it was always forgetting to do that, and then this just goes in a loop somewhere behind the scenes, which is quite annoying. Can also do some specific thing. remove all cells below focused one. Focused here. Good.